Hi, welcome to part 13 of Electromagnetic Induction. In this video, I shall explain the solution of question 6.13 on page 231 of Physics NCERT Part 1. This is from Chapter 6, Electromagnetic Induction. The question says, it is desired to measure the magnitude of field between the poles of a powerful loudspeaker magnet. A small flat search coil, this is the search coil, of area 2 centimeters square, area of the coil is 2 centimeters square and the number of turns is 25, is positioned normal to the field direction. This is the first position, and then quickly snatched out of the field region. Equivalently, one can give it a quick 90 degrees turn to bring its plane parallel to the field direction, just as this. The total charge flown in the coil measured by a ballistic galvanometer connected to the coil is given as 7.5 millicoulombs. The combined resistance of the coil and the galvanometer is 0.5 ohms. Estimate the field strength of the magnet. We need to find out what is B. So, we analyze the question first. The coil is placed such that its plane is first normal to the magnetic field. This is the first position. The area of the coil is given, number of turns of the coil is given. The coil is then snatched out of the field region or is given a quick 90 degrees turn to bring its plane parallel to the magnetic field. Okay, there is also a small galvanometer, ballistic galvanometer connected to the coil. So when it is given a 90 degree turn, this comes here. This galvanometer measures the charge as 7.5 millicoulombs. The resistance of the coil and the galvanometer together is 0.5 ohms. We need to find out what is the field strength. So coming back to the first position of the coil, this is the first position wherein the plane of the coil is normal to the magnetic field. The area vector is also perpendicular to the plane of the coil. In other words, area vector is parallel to the magnetic field. So the angle theta between the area vector of the coil and the magnetic field in this case is 0. In that case, cos theta becomes equal to 1. So the flux linkages in the first position is given by B dot A, that is equal to BA cos theta being equal to 1, phi flux linkages in the first position is equal to B into A. So as the coil is quickly snatched out of the field region, flux immediately becomes equal to 0. Flux linkages becomes 0. Equivalently, one can give it a quick 90 degrees turn to bring its plane parallel to the field direction. In this case also the flux becomes 0 because the area vector is in this direction. So the angle between area vector and B becomes equal to 90 degree. So the theta, the angle between A and B becomes equal to 90 degree. In that case, cos theta becomes equal to 0. So the flux linkages in this position of the coil is BA cos theta being equal to 0, flux linkages are 0. So If the coil is quickly snatched out of the field region, the flux linkages become zero. Equivalently, if the coil is given a 90 degrees turn to make its plane parallel to the magnetic field, even then the flux linkages become zero. So the flux linkages change from BA to zero. Since there is d phi dt, there is induced EMF. Since the flux is decreasing, d phi dt is negative. So induced EMF can be written as N d phi dt. Because of the induced EMF, there will be induced current given by E by R, which is also written as N by R d phi dt. We all know rate of change of charge is equal to current. So the same equation can now be written as dq dt is equal to N by R d phi dt, or we can write dq as equal to N by R d phi. So dq is equal to N by R d phi. If we integrate both sides, we get q is equal to N by R phi. And putting the values of phi, we get N by R into BA. So QR is equal to NBA, or B is equal to QR by NA. So if we put the values of Q as 7.5 into 10 to the power minus 3, R as 0.5, and number of turns is equal to 25 into area of the coil being as 2 into 10 to the power minus 4, we get the value of the magnetic field strength as 0.75 Tesla. So in case of any doubts or clarifications, please log on to www.olympiadtester.com/mentor. Thank you.